Yeah, right now it is visible.
Okay, please continue.
Okay.
Please continue.
Okay. Thank you. Thank you. So this is the absorption spectra what I have left due to network problem. That is not an issue everywhere right now is a problem. So three phases basically mixed phase and lattice phase and rutile phase actually shown here in this graph. Among this mixed phase shows a enhanced light absorption coefficient. So pure lattice phase absorb a greater portion of the visible light. It can be clearly seen that due to its dye absorption ability. In case of rutile phase TiO2 possesses excellent light scattering characteristics due to its high reflective index. Next slide, we can see that the XRD of these three phases. So, in the next slide, anatase phase exhibit a strong diffraction peaks at 25 degree and 48 degree for rutile 27 degree, 36 degree and 55 degree. So this among these three, anatase is better option. Basically, it indicates its results that DSSC it provides dye-sensitized solar cell. Basically, it's known as, so we can say abbreviation is DSSC. It provides higher surface area due to its crystallographic orientation, lower recombination rates. Arindam sir, go to the next and next slide. Uh, okay, this is the XRD graph, and next after we can see that ACM of the uh, uh, DSSC cell. It is observed that gap between the particle increases for mixed phase, creating more porous structure. Surface seems rougher. Sir, go to the next slide. And more uneven. It can be visible. Yeah, this is the three ACM of three phases. Uh, from it can be seen that the gaps between the particle increases for the mixed phases, creating its more porous than other structure. Surface look like more rough and more uneven. This is advantage of scattering to increase the absorbed tone by dye molecules and a large photocurrents. So the efficiency also compared for these three phases, it can be clearly visible from this table that a mixed phase shows a high open circuit voltage and short circuit current also. So that's mean this is basically room temperature deposited film. So it is expected that 101 and 200 anatase phase are mainly responsible for significant enhancement of the performance of this photovoltaic cell. In graphite, zinc, gallium doped zinc oxide, counter electrode, and mixed TiO2 based disensitized solar cell structure, interfacial electron transfer occurs from the rutile phase to the anatase phase more efficiently. Another example in the next slide, I have shown that a perovskite based cell, a perovskite layer is formed on a Zedono AL and Zedono GA doped thin film. On a glass substrate, first of all, we have deposited the Zedono AL and another one Zedono GA film, and then we have deposited the perovskite material on it and studied its performance such as electrical, optical, and etc. The next slide, sir. Next one. Next. So we have taken the two type of aluminum doped zinc oxide and gallium doped zinc oxide as a tissue layer, and then after we deposited a perovskite layer on it, and then we studied the its performance of crystalline surface morphology, and then after then how it will affects on the performance of a perovskite based solar cell. That is basically we have studied in this paper basically. So go to the next one. This is the absorption basically absorption spectra is shown there. The after deposit of perovskite layer onto TiO2 ZnOga glass layer is, shows higher. Then we studied the XRD. XRD spectra of perovskite deposited on glass is shown in the next slide. That is SAR peak is shown. Next slide is showed SAR peak at 110 and 220 and 310. All the peaks are for perovskite material that is shown in next graph. So peak indicating that tetragonal perovskite structure is formed. So go to the next slide. That is for XRD. Yeah. Next one is the same image, scanning electron microscopy image of the TiO2 powder sample was shown where nano surface grains are formed. Basically, after heat treatment, the surface seems rougher and more uneven, which is appropriate for perovskite solar cell. So, this is the basic requirement of a perovskite solar cell, this tissue materials. If you go to the next application, that OLED. Sir, can you go to the next application, OLED? That is more popular right now. Organic light emitting diode, that we have seen that the OLED TVs and that is on the market. So this here also we perform that gallium dope zinc oxide thin films is considered the anode materials, and then studied the competitive studies that commercially established film tin oxide and fluorine dope tin oxide, indium dope tin oxide. We compare to that of our result with that of the commercially established thin film. So here we deposited that film with a thickness of 170 nanometer. It's considered as a anode material. Its optical transmission shows more than 90% in the visible region of the solar spectrum. So device architecture is basically shown here in a diagram. So many layers are there: electron transporting layer, hole transporting layer, electron blocking layer, hole blocking layer, buffer layer, anode and cathode, or it's maybe called counter electrode is there. That is the basic structure. Whatever we have fabricated, basically we have fabricated. We deposited the tissue films, and this entire fabrication will be done in the Taiwan. Okay, one of our collaborators helped us to fabricate this OLED on our deposited tissue samples. So next slide, the AFM shows the surface morphology. Here it's different, quite different with that of other two applications. Here need the surface is not too much rough, grain size is smaller. So in previous one, in DSSC and perovskite solar cell, it's required a rough surface. That's mean more light will be absorbed in this throughout this layer on this porous layer. Okay, so from here it's different. Figure shows that the surface morphology and roughness of the sputtered ZnO and Ga and SnO2F. The surface roughness of the aluminum doped ZnO shows 8.74 nanometer, whereas for fluorine doped tin oxide shows 35 nanometers, quite higher comparatively for that application. Surface roughness is also one of the important factor in the performance of OLED. In OLED fabrication, anode material surface should be smooth as much as possible, because some roughness means there is some spikes is there. It can be clearly seen that from the AFM, the so many spikes are there. This spikes is the anode layer may causes a breakdown of shortening of diode, which in turn reduces the stability of the device basically. So the smooth surface of the electrode increases the lifetime of the OLED. The 3D topography of this AN dot GA dot Gedeno zinc oxide anode surface with low surface roughness basically. So gallium dot zinc oxide anode based already shows a more lifetime compared to the commercially fluorine dot tin oxide anode based OLED. From the next, we also perform some characteristics such as its luminescence, current density, quantum external quantum efficiency of this device, and also compared with the commercial and our sample that is shown in the next slide probably. Yeah, this one. From this figure, it can be clearly visible that two colors is given for two types of samples and different parameters such as higher luminescence, current density, and external quantum efficiency, and this one is given there. So it can be said that SNO2 shows higher luminescence and higher current density when compared to the other one. The driving voltage each devices with SNO2F is around 3.4 volt at 100 ZD per meter square. For gallium dot it's 4.2 volt. This increase in brightness was due to the high current density in SNO2F, fluorine dot tin oxide. External quantum efficiency, if you compare there, it can be clearly visible that the value is not given there. I just say the value. It's for Gedeno GA 8.7%, where for fluorine dot tin oxide it shows 6.5% of external quantum efficiency. So in case of maximum current efficiency, the power efficiency of fluorine dot tin oxide is 23.16 CD per ampere, and for gallium it's 11.91 milli per watt. Okay, so the poor efficiency in the fluorine dot tin oxide stems from the unbalanced charge inside the OLED. So that is the factor that reducing its performance. So from EL spectra for the both devices shows in the last one uh, uh, graph green light with a peak of wavelength 516 nanometer for gallium dot zinc oxide, and for tin dot it's 524 nanometer. So that's mean we make a conclusion from this comparative study that from commercial sample shows higher luminescence, low driving voltage, current density. Still, Gedeno GA shows higher external quantum efficiency. So that only a reason that we found that unbalanced charge inside the OLED makes the lower efficiency of the commercial sample. That is the comparison, and we made a study on that. Next one, sir. Next one. So beyond that, I am applying for my research for these three devices: VSSC, perovskite, and OLED. So this photovoltaic cell or solar cell is applicable also in different, as you know that in household application, charging point, satellite. These are the few applications present in present day. So many applications are increases for these solar cells, and I would like to conclude my lecture. So before conclusion, I would like to acknowledge my institute, Haldia Institute of Technology, my chairman sir, Dr. Lakshman Chandra Seth sir, Register sir. Also, I would like to very thank to uh, uh, our convener sir, Arindam Ghosh sir, being arranged such a
a beautiful speech for me and arrange a schedule for me. I'm very much thankful to him and also his university and all the chairman and registrar of your university. And finally, thanks.
Hello.
Yeah.
Hello.
Yeah, audible.
Audible, na? So,
Yeah.
first of all, I want to thank you, Himadri Sekhar Das, for such a beautiful and informative lecture. And in this very short duration, he has arranged such a beautiful lecture. And I am also very much thankful to all the audience who is on the screen and off the screen, and there are a lot of audience are also available who is not being able to being participate of this function. So for them I want to say one more thing, that this total lecture is available in the YouTube channel. You can refer anytime. Okay, and for the some technical issue, some part of the lecture has not been updated in the single video, but the recording is also going on, so I will update it the second part very soon. And last but not the least, I want to say thank you for first of all the Himadri Shekhar Das sir and the audience, the chairman of my institute, and the vice chairman, the chancellor sir, and the registrar sir, and all my colleagues who have supported me throughout the for conducting this type of beautiful program. And I am also requesting all of you should fill up the attendance sheet and feedback form. Okay, after this sometime I will open it for another 5 minutes. So if you not being able to fill up the feedback form and attendance sheet, please fill it up, and I will send you the certificates earliest within 2 to 3 days. You are going to get the certificates, e-certificates you are going to get. So, and if you want any more lecture and you just suggest us the topic, so we can make available the speaker in front of you. So thank you very much, and now the session is open for feedback. So आप जो यहाँ पर फीडबैक देना चाहेंगे, आप आपका वीडियो चालू कीजिए और आपका फीडबैक प्रदान करें प्लीज. So should I take some names, or will you be voluntarily be available for the lecture? Shobhana Mishra, are you available? Shobhana Mishra. Shobhana Mishra, are you available?
Yes, sir.
So please tell something about this program, and I want
Sir,
to
program by very খুব ভালো লেগেছে স্যার.
আপনি প্রথমে আপনার ইন্ট্রোডাকশনটা দিয়ে দিন একটু. Or if anyone want to give the suggestions or feedback, please you are feel free to talk. So EC 176 Sogato, are you there? EC 176 Sogato, are you there? Please open your video.
वीडियो सर.
वीडियो चालू कीजिए आपका खुद का.
यस सर.
और आपका प्रोग्राम का बारे में कुछ सजेशन दीजिए. योर फीडबैक.
Program is sir very well and the solar cell knowledge is solar cell program diagram basis, and the PPT is very well, sir.
गुड। आप कहाँ से हैं?
मिदनापुर सर।
गुड। आप क्या कर रहे हैं? बीटेक चल रहा है क्या आपका?
हाँ सर, बीटेक
कौन?
हल्दिया इंस्टीट्यूट से सर।
गुड। Onimes Manna, are you there? Sogato, Onimes Manna, are you there? Onusri Jana, Onusri Jana, आप जो बोलना चाहते हैं खुद अनम्यूट करके बोल सकते हैं। बसंत कुमार, बसंत कुमार, गोविंद दास, गोविंद दास, गोविंद सिंह, तो आप कोई बोलना चाहते हैं तो बोलिए, अदरवाइज मीटिंग को मैं यहाँ पर ही क्लोज कर रहा हूँ। Am I audible to you?
Yes.
आप और कोई कुछ बोलना चाहेंगे, कुछ सजेशन देना चाहेंगे तो यू आर मोस्ट वेलकम।
Thank you very much for your precious time and giving a better lecture as a research paper in the field of the photovoltaic cell as a solar energy. As the temperature increases nowadays and global warming is just warning me as a, that's happened. So we want to use our energy as well as all the sources in the form of a reliable energy. So that's thank you for giving your precious time on your research paper. So then thank you very much to your previous time and understood. We all are the student of from the engineering departments, and mostly I think all the students belong from the electronic communication and electrical energy. They better know that how the energy is transfer from one form to another form and how we can use and what we have the precautions and what I have learned. So thank you for giving your precious time. Thank you.
तो आप सभी ने आपका फीडबैक फॉर्म और अटेंडेंस भर दिए ना? आप लोग सब भर दिए तो मैं मेरा मीटिंग को
Yes,
क्लोज
sir.
करूं? और कुछ बोलना
Yes,
चाहेंगे, कुछ फीडबैक देना चाहेंगे आप लोग? क्योंकि आपका फीडबैक हम लोग का आगे का प्रोग्राम को और भी बेहतर करने के लिए सहायक होता है। इसीलिए मैं आप लोगों से बार बार विनती कर रहा हूँ कि आपका फीडबैक दीजिए, हम लोग का जो जो मिस्टेक्स है उसको भी पॉइंट आउट कीजिए, ताकि हम लोग आगे चलकर और भी अच्छी तरीके से आप लोग को वीडियो प्रोवाइड कर पाए। तो किसी का कुछ मैंने और कुछ कोई बोलना ना चाहे तो मैं मेरा यहाँ पर वेबिनार ख़त्म कर रहा हूँ। थैंक यू वेरी मच।